Alright, if we look at example 11, I don't want to dwell too long on example 11 and 12. I think you guys are really getting the basics of these integrals here. We can separate them out into individual integrals, or you can see that we're just really taking the antiderivative of each term there. If we look at example 11, alright, we're going to write each one of these in terms of x. So we're going to factor the 8 out in front of the integral. We're going to factor the negative 9 out. Alright, and we're going to leave 4 alone. So we're going to have these three different integrals. And by now we should know how to do the antiderivative of x cubed and get x to the 4th over 4. And we should know the antiderivative of x squared is x cubed over 3. And we should know the antiderivative of 4 is x. Notice we have these three constants, but since they're all constants, and when we take the derivative of a constant as 0, we can write them as one constant of integration. So that's why we can either break them into individual integrals or just kind of do them all at once. Now what you do have to do is make sure that you reduce. So notice 8 divided by 4 is 2. 9 divided by 3 is 3. Alright, so we've reduced those fractions down. So our final general solution here is 2x to the 4th minus 3x cubed plus 4x plus c. So really the difference between example 11 and example 12 is example 11 I wrote these all as individual integrands for you. Whereas example 12, I think we can do this one mentally. So we take each term. Alright, keep the constant in front, try not to simplify right away, but take the antiderivative of each x term that you see. Alright, so the antiderivative of x to the 4th is x to the 5th over 5. Antiderivative of x cubed is x to the 4th over 4. Antiderivative of x squared is x cubed over 3. So on and so forth as we go down the line here. Once you get to this point, we're able to reduce the fractions. So 10 divided by 5, 8 divided by 4, 4 divided by 3 is going to stay the same. 10 divided by 2, and so on and so forth. So we can simplify all the fractions out. I know you can't see that real well, but it'll probably pull up okay when you pull up the PDF version on my website. Alright, this one, it looks challenging. It's really not. You guys are all more than capable. Notice we're taking the integral of the third root of x squared dx. So just remember how to rewrite our exponents here. We've got to rewrite that radical as x to the 2/3. Alright, so the power on the x, which is inside the radical, becomes the numerator, and the actual root that we're taking is the denominator on that exponent. Now it's just simply applying that, undoing the power rule. Alright, so 2/3 plus 1. Remember when we do plus 1, it's 3 over 3 in this case. So 2/3 plus 3 over 3 is 5/3. And then we got to divide by that 2/3 plus 1, which is 5/3. Now remember, we have to multiply the numerator and the denominator by 3/5. So the denominator goes away and becomes 1. So we have 3/5 x to the 5/3 plus c. So when we see these, don't get too scared. Just know that you've got to rewrite that integral, or not just the integral, but the x term, and just making sure we're keeping track of which goes to the numerator, which goes to the denominator when we're rewriting the radical.